I think we are coming from a concept of oversimplification of the aspiration process to a concept of aspiration can be a little bit optimized. It can be tailored to the target vessel. And when you deep dive into the science of aspiration, as Penumbra promoted, it's interesting to see that you cannot reach the same effect if you do not follow a good sizing. Typically, in my first experience, I was used to take the largest diameter of catheter I had and to track it as far as I can, because I thought that the largest was the lumen, the more efficient would be the aspiration on this target clot. But when you deep dive on the physics of it, you understand it's not the case. So you are switching from a paradigm to taking the larger thing you can track, the more distal you can track, to something that you should be extremely focused on having the exact catheter size in order to preserve the flow surrounding the catheter. So this is a game changer in terms of spirit, since you add technicity into the understanding of aspiration to preserve the flow around the catheter, so you have to size the catheter precisely. And when you see the difference of size in between the vessels in the brain, you go to 1.2, 1.5 to 2.7. So the margin, the range in between is quite small. Okay, it's not like 3 or 4 millimeter of difference, like half a millimeter, sometimes 1.3 millimeter inside. So if we want to promote the level of technicity of the aspiration and preserve this concept of preserving surrounding flow around the catheter to get the maximum benefit of aspiration, then you need to size. You need to size before selecting the catheter. We used to have 2 sizes, now we have 5 sizes. So yes, I think the extension of the portfolio allows us to think different with aspiration. This concept of aspiration, I think, has to be understood in opposition to ingestion. If you want to bring something very big into a vessel, and the diameter of the catheter may be beyond the diameter of the target vessel, then you are enlarging the vessel yourself with the catheter. And now you can still apply a force to something, but it is just a force to the thrombus. And once this is done, you are more prone to get a collapse of the artery, because there is no flow surrounding the catheter. So you are vacuum the rest of the blood, squeezing the vessels, and this is a question. This may work, but this may also harm. And we all have cases, we can remember that with oversizing, we got some dissection of the vessels. This is an important finding, that on the bench test you observe an increased efficacy of the aspiration when you are just below the target diameter. When you are just below the target diameter of the vessel in terms of OD for your catheter, you let the systolic flow coming around the catheter, and it helps on one side to push the thrombus inside, because you increase the gradient of pressure between the outside of the catheter and the inside of the catheter, because you still have, in addition, you don't have 0, but you have the pressure of the arterial pressure. So this is a gain of efficacy. And secondly, if you still have not the whole thrombus in one aspiration and you still have vacuum, then you can still have distant clots that are not initially captured by the catheter, because the flow and the aspiration is still going on. If you are blocking the vessel after the first part of the thrombus being ingested, then you cannot vacuum anything else, because there is no reverse flow induced by the technique. So this bench test evaluation and this concept promoted by Penumbra is extremely interesting. Of course, this has to be validated by clinical study of safety, showing that prospectively doing exactly this technique, checking this technique will achieve better safety, better results. But we have to pay attention. The compatibility is just essential. I mean, that means that you can play with one catheter, for example, and if the size was not really appropriate, you can, over the first one, bring a larger diameter and then complete the treatment. Or reversely, if you have a bigger size for a first pass, then you have a distal migration, you can complete the treatment, not changing anything else than adding another longer catheter in to reach the distality. So yes, it's an essential point. The future of thrombectomy is reproducibility, mass treatment, ease of use. So there is two ways of thinking about that. So you put robots everywhere, that's probably unlikely, or you train people with very straightforward technique that you can teach easily to different sites. That maybe could be the first doable step to fill the gaps of the thrombectomy services, because you know that there is lots of white area where the thrombectomy service is under the average ratio in each country. So you have lots of area that needs to reinforce the thrombectomy services. One innovation we're expecting is beyond this catheter adaptation in terms of size, the intelligence of aspiration, because we understood that this aspiration could be performed in different way. If it's too strong, it can also promote collapse, vessel collapse, and the energy you can put in the aspiration can change also the friction forces in between the thrombus and the catheter inner lumen, and can completely change the efficacy of the aspiration as well. So we are truly also waiting the innovation in this field. Hopefully, I know studies on his way, so we will be very attentive to the results.